So let me show you what I do to determine whether wires are good or not. What you need: a tape measure, calculator, multimeter, a pen, and something to record on. So it's easiest to measure the length in inches. And so resistance is ohms. So the little omega is the unit for resistance, and it's considered ohms. If you see a K before it, it's kilo ohms. All right, and so if you want ohms per foot, you can just take your ohms per inch measurement and multiply it by 12, and that gives you ohms per foot, resistance per foot. All right, we'll pause it and get everything set up. All right, so I have here a Moroso Blue Max wire. Originally they were all blue. Now you can give them different colors. And as you can see right here, it's printed right on the insulator that they're measuring, that they're supposed to be 800 ohms a foot. All right, so this one is approximately a foot long, and you can see the measurement. So I've got a lead connected to each end of the wire, going back to my multimeter, and it's reading 720 ohms. If you're observant, that's 0.720 K omega, so that's 0.720 kilo ohms, which is the same as 720 ohms. All right, so this one is rated at 800. It's actually a little bit better. Maybe I've trimmed a little bit extra off. So anyway, it's well within spec. It's right about where I would expect it. So this is a good wire. All right, next up, I have one of the Taylor wires, and I measured these earlier, and so this one's only reading 98.7 ohms, so it's a lower resistance wire. So like the other day I measured, and this one was actually, I measured 100 ohms the other day, so it hadn't changed much, just the way I actually changed the wires going to my multimeter, and that's probably resulting in the 1.5 ohm difference. Measured it at 25.5 inches. Go to your calculator. We'll say 98.5 divided by 25.5. So 38.6, so we'll say this is about 40 ohms a foot. So it's really, the Taylors are a really, really low resistance. That sounds good. You can do your own research. They have to have some resistance to have EMI, RFI suppression. So anyway, but still Taylor's proven to be a good wire, so that's a good wire. Now I'll show you the second wire. Okay, this is the wire that caused me to make this video. If you look at my numbers, I mean, I'm getting 100, 104. I mean, as they got longer, there's some variability, but they're all really close to 40 ohms a foot when I measured these. So good wires, except I got to this one wire, the second longest wire, and I got no reading, off the limits. So I'm connected here, and I'm connected here, and I'll even fish this around, and hard to see, can't see both, but usually I should be getting, this is shoved up in there. So I'm getting no reading at all. I'm getting the same reading as if the connector's not even touching the wire. That's rare. Usually, even if there's a bad spot in the wire or a subpar crimp in one of the terminals, I usually get a higher reading. You know, maybe it would read 1,000 ohms instead of 100 ohms or 1,500 ohms or something, but I've never actually seen it where I've got no electrical flow at all. So next I'm going to tear into this wire and see if I can determine the reason I've got no connection. I've got a hypothesis. I'm thinking that maybe inside one of these two boots, I'm going to find that the factory didn't strip off the insulation and the conductor is physically not touching the connector that's inside. That's my hypothesis. Okay, I'm back. I found the issue. So I started by removing the wire off the spark plug boot end because that's the easiest one to remove and put back on, because the terminal just fits right up in here. It slides in and out pretty easily. I tested it and I got still no resistance. So I determined that I could see. Let me see if I can take this off. So you can see the conductor is in there and it's folded under right here. And so the terminal is making contact with the conductor. So this end is good. I'll reconnect my lead. All right, so this end was the 135-degree side. Let's see if I can, oh no, my battery's, okay. Starting to lose my battery here. All right, so you can see out of limits. Have the dexterity to do this. Let me see. So I've clipped my lead onto the little small screwdriver to work as a probe. You can see that I'm getting nothing there. The conductor is harder to see in this one. It's down in there, but it's watch this. I've got the screwdriver directly on the conductor. Now I'm reading 143, 144 ohms, which is good. Now, I'm not reading off the terminal, I'm reading right on the conductor. So when I pull it off and go to the terminal itself, I've got a broken connection. So I've just diagnosed the issue is that the spark plug wire terminal is not making contact with the conductor of this wire. And that's what I need to repair. So if you'd put this set on your motor without checking it, you would have a completely dead cylinder. The motor would be running bad, it would be sputtering, it would be jerking, and you'd probably be thinking the camshaft is bad or the carburetor is bad or something else. You're like, it can't be the spark plug wires, they're brand new and high quality. But it was the spark plug wire. Okay, now I have removed the terminal. I've stripped the wire a little bit more. I'm connected to that end with that lead. And see if I can. (140 ohms), right about where it should be for this length. So at this point, I'm doing good. Now I got to reconnect the terminal, and I'll double check again before I put the boots on. Show this real quick. Looks like a pencil sharpener. It comes with most of the MSD, excuse me, not the MSD, the Moroso Blue Max wire kits for the ones where you assemble them yourself. It does a great job of stripping the insulation without hurting the conductor. You just basically slide the wire in and twist it like you do sharpening a pencil, and then when you get to the end where you want to finish, I put my thumb underneath, hold it in place, and make a few twists. And I can't really tell that. But after a few turns, it makes a cut in a circle, and you end up with a really nicely stripped wire with a conductor that hasn't been compromised. Okay, one thing that does make this job a lot easier is having the proper crimpers. And the rear jaws are the ones that I used. Yeah, they basically went on like that. And crimped the terminal on. I still have this end connected to one lead, and off limit, out of limit. So here's my newly crimped terminal. And if you remember my resistance reading a while ago, I have the same reading now. And disconnect it. It gets back to outer limits. So now all I have to do is put the boots back on this wire, and this wire will be good to go. A little bit of silicone grease, silicone spray, or even WD-40 will help you slide the boots back on. And it also helps slide the boots off when you're disassembling them. But now we have this wire, 140 ohms, fits in right there. So it's in line with everything else. So we now have a good set of wires.